Here's another example of an equation. Unfortunately, this is not a linear equation in one variable. When a variable is here in the denominator of a fraction, that changes its exponent from being positive 1. So in fact, do you remember when you have 1 over x, do you remember what that's equivalent to? Remember, that's equivalent to x to the negative first power. And if you're fuzzy on your negative exponents, that's something we'll be reviewing. So this is not a linear equation in one variable. It is what we term an example of a rational equation, an equation that has fractions, and we've now introduced into the denominator of the fractions the variable. So the technique we're going to use to solve this kind of equation is similar to what we just got through doing with our linear equations in one variable that had fractions. We're going to get rid of the fractions first, and then whatever kind of equation we create after that, we will solve with whatever is the appropriate method. So we need to pick a multiplier that when we multiply both sides of the equation, it will cancel all of the denominators we have here. Well, wouldn't the number 18, if we multiplied every fraction by 18, wouldn't that cancel the numbers that are here in the denominators? But we also have an x that we need to cancel. So the correct multiplier we need to use here is the multiplier 18x. So I'm going to take both sides of this equation and multiply by 18x. Can I just do this as far as writing that that's what I want to do instead of having to rewrite the entire problem? And now I want to distribute that multiplication times all those terms. So it's going to be 18x times 5 over 2x minus 18x times 8 over 9 equals 18x times 1 over 18 minus 18x times 1 over 3x. Now I'm going to perform those individual multiplications. Well, here, the x's will cancel each other, and 2 goes into 18 9 times, so I have 9 times 5 is 45. 9 goes into 18 twice, so I have 2 times 8 is 16 times x, I have 16x. The 18's cancel, leaving me x times 1, which is x. The x's cancel here. 3 goes into 18 6 times, leaving me minus 6 times 1 is 6. And I have simplified the equation tremendously over what it was originally. And now it's a linear equation in one variable. That's not always what happens. Sometimes when you have a rational equation and you multiply through to clear out the fractions, you can sometimes create other types of equations besides linears. You might create a second degree or quadratic equation. You have to perform that removal of the fractions first to know exactly what kind of equation you have. Now we can just go through the process of simplifying this. Let's add 16x to both sides so that we only have the variable in one term. And again, I did that by adding 16x to both sides, kind of doing a little shortcut, leaving out that extra step, and then I put it back in just to make sure you understood it. And now let's add 6 to both sides. So we have 51 equals 17x. When I divide both sides by 17 to get a coefficient of positive 1, I have x equals 3. So the solution to our rational equation we have here is x equals 3. If we were to substitute 3 for x back into the original equation, it would make the left-hand value the same as the right-hand value. Now, one thing you have to be careful of when you're solving rational equations where the variable's down in the denominator, you have to be careful that the solution you put in doesn't produce a problem in your denominator. And remember, one of the problems in denominators of fractions is the denominator cannot be 0. Well, if we plug in 3, it's going to make this denominator 6, this denominator 9. what would be the value of x that if you plugged it in there, it would make either of those denominators become 0? That would be 0, wouldn't it? If you plugged in 0, 2 times 0 would be 0, or 3 times 0 would be 0. So in this case, what we call the restricted value on x is x cannot be 0, because it would have made the denominators become 0, and we can't allow that. But our solution was not 0, our solution was 3, so we don't have to worry about that restricted value. But you always want to be aware of those restricted values on the variable when you're solving these kinds of rational equations.